Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, our today's topic is very important, that how we can prepare loan amortization table by using ordinary annuity. So let's start our exercise. Suppose today the loan amount is rupees 50,000, say 5 lakh, and the interest rate is 10% per annum. Number of years in which we are going to pay end of year installment are 5 equal cash flows. Present value interest factor for given interest rate for given number of periods. Before this consideration, before starting this computation, we know that present value of an ordinary annuity is equal to payment multiplied present value interest factor of an annuity for given number of periods and for given number of interest rate. We know this computation, we can use it by manually, by calculating, by using the hand calculator, by using the table values. Then we find payment is equal to present value of an ordinary annuity divided by present value interest factor of an annuity for given number of for given interest and for given number of periods. Now, the loan amount, that is the 5 lakh, is the amount which we are borrowing today, and it is the present value of an ordinary annuity, because it has been asked that you will have to pay the 5 equal end of each year installments. So by using this computation, we will find present value interest factor of an annuity by using only this component, that is equal to 1 minus 1 over 1 plus I interest rates, whole power is n number of years. We will close this function, then we'll divide by interest rate and we'll close this function. And it is 4. The interest factor is 4. Let it be in rounding to 4 elements. $3.79048 is the present value interest factor of an annuity for a given interest and for given number of periods. Now we will find out payment end of each year. End of each year that we will have to pay. We know that the present value of ordinary annuity is 5 lakh, and present value interest factor for given interest rate for given number of period is 3.7908, that we have computed by using this computation. So let we compute 5 lakh divided by 3.7908. Now our installment is 1,31,899. So we have rounded this installment, and the total amount that we are going to pay for 5 years, we will have to pay this installment multiplied 5 years. हम 5 सालों के ऊपर 5 लाख के लोन के अगेंस्ट 6,59,494 अमाउंट जो है वो पे करेंगे. 6,59,494 59,494. So the interest amount is the difference, that total amount which we are going to pay minus the loan amount today. And the interest which we are going to pay for 5 years, 1,59,494. So इट्स वेरी क्लियर, 5 लाख का हम लोन लेते हैं, हमें उसके ऊपर पे करना पड़ रहा है 6,59,494 और जो डिफरेंस है इन दोनों का वो हम जो है वो इंटरेस्ट की जो है वो मानंद पे कर रहे हैं। अब हमें लोन अमोर्टाइजेशन टेबल प्रिपेयर करना, इसकी जरूरत क्यों महसूस होती है? वो इसलिए कि हमने ये जो 1,31,899 की एक इंस्टॉलमेंट है, इसको बाइफरकेट करना है इनटू 2 कंपोनेंट्स, दैट ईच ईयर इस एक इंस्टॉलमेंट में हम कितना इंटरेस्ट पे कर रहे हैं, ताकि हम अपनी इनकम स्टेटमेंट में हर साल इंटरेस्ट एक्सपेंसेस टू इंटरेस्ट पेबल और इंटरेस्ट कैश की ट्रांजैक्शन जो है वो करते जाएं। एंड सेकेंडली, we will have to retire our debt from the balance sheet, from liability side, from long-term debt. हम जितना प्रिंसिपल अमाउंट पे करते जाएंगे, हमारी लाइबिलिटी उतनी रिड्यूस होती जाएगी। लिहाजा हमें 5 ईयर अपनी अकाउंटिंग रिक्वायरमेंट के लिए इस लोन को का जो है वो अमोर्टाइजेशन टेबल जो है वो रिक्वायर्ड होता है, ताकि हमें लाइबिलिटी का भी पता चलता रहे कि वो कितनी ड्यू रह गई है, और इंटरेस्ट की रिकॉग्निशन रिगार्डिंग टुवर्ड्स द मैचिंग प्रिंसिपल we will have to count it for each accounting period for income statement. End of each year, 1, 2, 3, 4, 5. The payment is equal to, we will write is equal to the payment amount, and we will fix it because it will remain same for each period. So we will tag it to for 5 years. Beginning of year principal is, the second column is beginning of year principal. The beginning of year principal is the amount of 5 lakh, the loan amount. We will start from this element. And the interest is simple computation, is equal to, as we have narrated here, columns 1, 2, 3 column, third column is equal to second column multiplied interest rate, multiplied interest rate. And the fourth column is equal to 1 minus third, that will be the principal amount from interest installment. And fifth column is second minus fourth. Let's compute in first instance. Is equal to second column multiplied interest, and this interest will be remain fixed because 10% will apply each year, and this element will rotate because these values will change. So 50,000, and the fourth column is equal to 1 minus third column. पेमेंट में से अगर हम इंटरेस्ट निकाल देंगे तो बाकी हमारी पहली जो इंस्टॉलमेंट हमने 1,31,899 की पे की है, उसमें से हम जो है वो जो इंटरेस्ट की अमाउंट हमने पे की है उसको हम निकाल देंगे, तो रिमेनिंग हमारा प्रिंसिपल बच जाएगा। दिस कॉलम माइनस इंटरेस्ट. So, and end of each year principal, that is the difference of second column minus fourth column, and second column is the beginning of year principal minus the principal which we have paid in first installment. So this difference is the, and again the ending of year principal for first year will become the beginning of year principal for year second, is equal to, we will report here in this manner. And if we will do this component up to here, and then we will take up to here, and it will report for the next value. Again, if we drag it, again, we will use the same computation. So let's let it again. We initiate from here. Let it compute. Okay. If we have computed, we have reported from the end of year principal will be the beginning of year principal for the second year. And then we will again compute by using this computation. The third column is equal to second multiplied interest. And then we will use the same style that from this installment, the C13 minus the E13 amount. And then we will use the same computation here. Again, we will use this practice from here because the first value is reported from this segment and all other values are reported from this element. Then we can easily track these values and we will get the required result. Okay, so it's very clear. In last installment, the whole payment has been made. Now the principal sum, we will use it. The sum of the principal is 5 lakh. Let it little bold. So 5 lakh, and the sum of the interest amounts will be 1,59,494. We may round this column as well up to format up to 2 numbers. So the computation let to compute to, ये हमारी अपनी मर्जी है हम कितने की जो है वो राउंडिंग करना चाह रहे हैं. अगर हम बिल्कुल भी ना करें तो वो कोई ऐसा इशू नहीं है और इस चीज को जो है वो हम यहाँ पे भी इसकी राउंडिंग को जो है वो खत्म कर देते हैं. So it's very clear that how we can compute the loan amortization table. Now we put any amount here. Let's see if we have loan amount 6 lakh, then automatically it will be computed and the last payment is. So all principal amounts liability and the interest expenses for each year. And the sum of both will be equal to the principal amount has been paid and the interest has been paid up. Any example, we can change interest rate as well. Let's see if we have 0.15 and 15% or 0.15, we can use the computation. So for 5 years retirement of the loan, we have modeled the installments, and in this way we can compute the loan amortization table. Now let's come towards the second concept, that is the computation of loan amortization table for annuity due. In annuity due, one interest factor is greater, so we include in present value interest factor multiplied 1 plus I. Again, we have loan of 5 lakh, interest rate is 10%, number of years 5, cash flows, and now we are going to compute the present value interest factor for an annuity, and then if we will multiply it with 1 plus I, it will become present value interest factor of an annuity due. So is equal to, let we start our computation, 1 minus 1 divided by 1 plus I, then its power is 5. We will close this function, divided by I multiplied with 1 interest factor 1 plus I11, and we will get 4.16987. It is the present value interest factor for an annuity due to compute the payment. Now the payment is for beginning of each year. Each year, that's equal to 5 lakh present value of an annuity due and divided by interest factor. Now the installment is 1,19,908. अगर हम कंपैरिजन करें तो हमारी प्रीवियस एग्जांपल में जो थी इंस्टॉलमेंट थी वो 1 लाख थी हमारे पास 31,899, जबकि अब हमारी जो इंस्टॉलमेंट कंप्यूट हुई है 1,19,908. The total amount that we are going to pay over 5 years, 5 multiplied the payment amount. It is 5,99,540. The interest amount is 5,99,540 minus 5 lakh. Here the interest amount is, that is 99,539.7. As the first installment is paid at time 0, so 0, we will start the first cash flow because beginning of year 1, 2, 3, and 4. The payment is equal to, and that we will make fix it this element. We will track it, and then beginning of year principal is equal to the loan amount, and that we will fix for first element. We know here the difference in preparation of the loan amortization table is that we are highlighting this element here, that in first installment there is no interest. The whole amount is principal amount. In first installment जो हमारे पास है यहाँ पे 0 इंटरेस्ट जो है वो होगा, और प्रिंसिपल अमाउंट जो सारी की सारी इंस्टॉलमेंट है that will be the principal amount. As the time has not been passed, so there is no any kind of interest. Beginning of year principal, second column minus fourth column, that is equal to. Now this amount will be reported here, and again now this process will work now as the time one period has been gone, and against this time period we will compute the interest is equal to our first interest computation will start from the start of the first year, when 1 year will be completed, is equal to this amount multiplied the interest, and we will fix this value. Now it will be 1 minus third column, and the value in second minus fourth completion. Now we will track these values, we will track it, we will track these values, and we will track these values. So our computation has been successfully performed, as we will format these values up to 2 numbers. Again we value here up to, we can round it wholly round, we can round it to 2, we can round it to 4, we can, it depends up to our computation. So now let we make the solutions for interest amount, that is 99,539, that was computed here. So, and in the same way, we will make a sum of these values, and it will be, sorry, again, we will make a summation. Let it take a sum. So 5 lakh value is there. Okay. Now it's very clear that we have computed these values and loan has been paid out in first installment. There is no any kind of interest. So we have computed the loan amortization table for an annuity due installment. Thank you so much. And we close this topic.